what exactly is a large language model? So, a large language model is a special kind of AI, what some people call a foundation model. And you can think of it like this. It's a huge foundational base of knowledge that gets built by feeding it just a staggering amount of text. The whole goal is for it to learn the patterns, the grammar, the facts, and even the really subtle stuff about how we humans talk and write. And this is where it gets kind of wild. All of its amazing abilities, writing poetry, explaining quantum physics, even writing computer code, it all comes from mastering one single, simple task, predicting the very next word in a sentence. That's it. All that complexity emerges from being exceptionally good at that one thing. So how in the world does just predicting the next word lead to something that feels like a genius? Well, the secret is scale. And let me tell you, when we say large and large language model, we are not exaggerating. First, let's talk about the data. We're talking about models trained on over 45 terabytes of text data. Now, to put that into perspective for you, the entire English version of Wikipedia is only about 25 gigabytes. We are talking about a library of information so huge, it's honestly hard to even wrap your head around it. Then you have the model's brain. It's made of billions and billions of things called parameters. You can think of each parameter as a tiny little knob that the model twists and turns as it learns, basically storing all its knowledge. A model like GPT-3 has 175 billion of those knobs to get just right. And finally, at the price tag, training one of these cutting-edge models needs a ridiculous amount of computing power. We're talking costs that can easily blow past $100 million. This is a massive, massive undertaking that only a handful of companies in the world can even attempt right now. But look, this isn't just about making things bigger for the sake of it. There's a proven principle in AI known as scaling laws. And put simply, it just means that the more data, the more parameters, and the more computing power you use, the smarter the model gets. What's truly fascinating is that once they get big enough, these models start showing what are called emergent abilities, skills they were never explicitly trained for, like reasoning. So in the world of LLMs, bigger isn't just better, it's a completely different ballgame. Okay, so we know they're huge, but what's the actual recipe? How do you really build one? Well, it turns out it really just boils down to 3 core ingredients. Believe it or not, the recipe is pretty straightforward. First, you need ingredient number 1, that massive ocean of data we just talked about. Second, you need a blueprint, a special design called the transformer architecture. And third, you need one single training goal for the model to focus on, predicting the next word or token. Now, the secret weapon in this whole recipe is that transformer architecture. See, older models used to read a sentence one word at a time, kind of like reading through a straw. But the transformer has this breakthrough feature called an attention mechanism, which lets it see the whole sentence all at once. It can figure out how important every word is to every other word, which is how it actually understands context and meaning. It's a total game changer. So that brings us to the training process itself, which is really just one gigantic feedback loop. The model gets shown some text with a word blanked out, and it has to guess the missing word. At first, its guesses are totally random. But billions and billions of times, it guesses, checks its answer, and then slightly adjusts all those internal knobs to get a little bit closer the next time. It just does that over and over and over. So, after all of that initial training, what you have is this incredible generalist. It knows about history, science, pop culture, a little bit of everything really. But its true power, that gets unlocked when we turn it from a generalist into a specialist. And that process is called fine-tuning. Honestly, this dog training analogy is perfect. That massive initial training, the pre-training, that's like teaching a puppy basic commands. Sit, stay. You get a good general purpose dog. But fine-tuning, that's like the specialized training that turns that puppy into a police dog. You take the general model and you train it just a little bit more, but on a much smaller hand-picked data set, say only medical textbooks, to make it an expert in one specific skill. So we've got this powerful, fine-tuned expert model. How do we actually use it? Well, it all comes down to how you ask. The instruction you give the model is called a prompt. And let me tell you, learning how to write a good prompt is becoming a really valuable skill. It's called prompt design. Because with these LLMs, the quality of the answer you get back is almost completely dependent on the quality of the question you ask it. Now, there are 2 main ways to go about it. First is zero-shot prompting. That's where you just ask it directly with 0 examples. Translate cheese to French. Simple. But for more complicated stuff, few-shot prompting works way better. That's where you give the model a couple of examples first to show it the pattern you're looking for. You're basically teaching it on the fly right before you ask for the answer. And this isn't some far-off future tech. You are seeing these techniques everywhere right now, powering those customer service chatbots, helping people write articles and emails, summarizing long, boring documents, and even helping programmers write and check their code. The uses are just exploding.